All right, hello everyone, and welcome to the first unit of MUS 105 Music Appreciation. This week we'll be focusing on pitch, dynamics, and timbre. This begins our look into the fundamentals of music. Through the lens of these three subjects, pitch, dynamics, and timbre, we'll be looking at some of the most important basic elements of sound making. Um, just in case you didn't see last week or the getting started video that I posted, my name is Kyle Berry. I'm a public school music teacher in London, England, but I grew up in Conway, South Carolina, went to Carolina Forest High School and USC for my undergrad, and went to University of Edinburgh in Scotland for my master's degree. I'm a tenor. I'm a keyboard player, an amateur luthier, a builder of instruments, and a composer of chamber music and miniatures, mostly. There's me from my school photo from the other year on the right hand side. But enough about me. Let's get into the actual topics that we're going to be covering this week. So, the first week of our class, we're going to focus on three of the most fundamental aspects of music. First, we're going to look at pitch. So how high a note is or how low a note is. Da 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 da. There's several pitches there for you. I'll probably sing throughout these videos a lot just because it's the closest instrument at hand. Dynamics, which is how loud or soft the volume of a note. And then timbre, or the book I think calls it tone color. This is an interesting topic. It's very interesting because it's so hard to wrestle with. In the English language and in most languages, we simply do not have an adequate array of words to deal with describing the sounds that we hear. So you'll start to notice how difficult it is and how imprecise it can be to try to define the tone color or the sound of one instrument versus another. For this reason, there's a famous line someone once said that writing about music is almost like dancing about architecture. It just simply does not translate. It's hard to get your ideas across, but we're going to try our best. Anyways. So first up, pitch. Your music or your textbook, which again you do not need to buy, The Enjoyment of Music says we tend to characterize any musical sound as one that has a perceivable and measurable pitch determined by its frequency. This pitch depends on the length or size of a vibrating object. Every sound that we hear comes from a sound source, and that sound source comes from the disruption of air pressure. Whenever you clap your hands or snap your finger, you are making a tiny disruption in the air pressure of the room or the space that you're in. These tiny disruptions float through the air in every direction, and when they reach one of our ears, then our eardrums resonate in kind with that disruption in air pressure, and we hear the sound. There's a great video on the right, which I encourage you to watch it. It spans the entire range of human hearing, going from 20 hertz all the way to 20,000 hertz. The thing that separates these is that a 20 hertz note is a note that vibrates at 20 times per second. All the way up to 20,000 times per second is when our hearing mostly gives out. For those of us who are a little bit older, you'll notice that your hearing will probably give out before 20,000 hertz. Younger folks often have a larger audible range than older folks do. As frequency of these vibrations ascends and descends, so does the pitch that we hear. Higher frequencies mean higher pitches, lower frequencies mean lower pitches. And then, as I said, humans can detect about between 20 hertz and 20,000 hertz. One word of caution for this video, some people say it does hurt their ears to kind of listen to this sweep, so it might be better, instead of wearing headphones, it could be better to just listen on the speakers of your computer and to not play it at a very high volume. But that's the basics of it. High frequencies, meaning that this sound, this variation in air pressure they're making is vibrating many times per second, makes high pitches, and if it vibrates very few, it makes low pitches. Ancient civilizations, including the Chinese and the Greeks, discovered this. They found out that if you took a string, and it was a really long, thick string, and when you plucked you could actually see the vibrations because there were so few of them. They noticed that those that sounded lower, and if you had a very small string, it sounded higher. What they started to notice, though, is that there were actual algorithmic and mathematical relationships between these vibrations. For instance, one of the earliest kind of noticings of early mathematicians was that if you did take a string and stretched it out taut and were to pluck it, and then you cut that string in half, that you got at what we now know as an octave. An octave is simply a note vibrating at twice the number of times per second as the note below. So if I sing da, and then I go da 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 da, the second pitch is vibrating twice as many times per second as the original pitch. Same thing if I go down an octave, I just cut the number in half. So they noticed this relationship. Thinkers like Pythagoras and Zayu, who we'll hear about a little bit later, also began to find that there were other sorts of mathematical relationships that you could get. Eventually, through relationships of geometry, we started to evolve to the scale that we have today. This video I have is really great. I show it to almost all my classes. It's from way back in 1959. It's called Donald in Math Magic Land. It's an early Disney film, and it kind of walks you through the discovery process of Pythagoras and how we got to our modern diatonic scale. Today, we have what's known as 12-tone equal temperament, meaning that on a keyboard, you can see here in the red box, there are 12 pitches. From here, you can see F, F sharp, G, G sharp, A sharp, B, C, C sharp, D, D sharp, E, and then after that would be F, and it's an octave higher, and you can notice that it repeats the pattern over and over. Patterns of 3 black keys and 2 black keys. With the white keys in between. So we have 12 notes. Today, our notes are equally spaced. So the distance from one note to the note right after it is exactly the space anywhere on the keyboard. If I go from this black key here, which is a C sharp, and I go down a half step, that is exactly the same distance as if I go from that black key up a half step. So this dates back a really long time. This was not always the case, but nowadays we have kind of a very precise measurement of the distance between notes. There are other tuning systems, however, even though in our system we only have 12 distinct pitches. Around the world in different traditions and heritages, there are all sorts of different divisions of the octave. And some systems divide the octave into 19 parts, or to 24 parts, or to 31 parts. And there are very unique instruments that have come out that these various cultures have developed in order to play these specific musics. To someone from these cultures' ear, it would not sound odd at all to have these notes that are in between the notes that we have. For us, it can be sometimes a little off-putting, a little unsettling, a little unusual, because it's almost like seeing colors that you've never seen before, or these extra notes that live in between the spaces of the notes that we have, make up unusual colors and unusual relationships when played in the context of that music. Again, here's a great video. I think this is Row, Row, Row Your Boat, but instead of the octave being divided into 12 parts, as we are used to, it's divided into 31 parts. These alternative systems, the Western music has labeled as microtonal, because obviously if you divide something into 12 parts and then you divide it into 31 parts, each of those 31 slices is going to be smaller than the 12 slices that we use, so microtonal. Dynamics is the next big idea that we're going to be discussing. Music will be incredibly boring, as I write here, if every note were played and sung the same. We like to hear musical lines grow and then shrink. We call this dynamic movement. If something changes over time, it's called a dynamic. If you, as an individual, do all sorts of different things in your life, and you go to one place one weekend and in a different place another weekend, and you work different sorts of jobs and you do different sorts of things. You're a very exciting person. You might call yourself a dynamic individual. Same thing with music. Music, as I said, would be boring if when we sang a song, it's simply every note was exactly the same. Row, row, row your boat gently down the stream. But by changing the pitch and by changing the volume of those pitches, I can get something a bit more interesting. Row, row, row your boat gently down the stream. Kind of grow in volume and shrink in volume. Forgive my singing, but you get the idea. By changing pitch on one level and by changing volume on another level, you can add additional intrigue to the musical line that you're playing. Dynamics provide expressiveness to a performance and provide composers with tools to shape their musical ideas, to have them played exactly as they would like them. Most of the ways that we classify dynamics in our Western musical tradition is through the use of Italian words. The two, though, that you really need to know are here: piano, not piano, but piano, and forte. Piano would mean one P. If you see it written in the music, it has one letter P. It means to play something softly. And F stands for forte, meaning loud. You guys probably all know the instrument, the piano, probably the most famous instrument in the world, possibly. Well, the piano's actual name is the pianoforte, because when it came out, it was this revolutionary instrument, keyboard instrument at least, that could play loud notes, or if you press the key softly, you could play soft notes. So that's where the name comes from. In between piano, meaning soft, if you want to be kind of soft, you can have mezzo piano. The next level up would be mezzo forte, meaning moderately or kind of loud, and then forte. For piano and for forte, we have ways of getting even louder or even quieter. If I want to be quieter than piano, if I add an extra P here on the symbol, it's called pianissimo. And if I add an additional P, 3 P's in a row, it would be pianissinissimo. Same thing with forte. Forte is loud, fortissimo is even louder, and fortissitissimo is even louder. And you can go as loud as you want to, as we see here. Mahler marked 5 Fs, fortissi, issi, 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 issimo, in his 7th Symphony, and Ligeti is known in his piano etudes to have marked 8 Ps. So very, very, very quiet. Sometimes, though, a composer might not want to just suddenly change the volume like a light switch on or off. One moment you're 100% loud, and then in the next moment you're 100% soft. Life does not happen that way. Music and art imitates life. Things happen gradually over time. And so we have a way to reflect that in music as well. We have these ideas of crescendo over on the right on the top and decrescendo on the right on the bottom. To crescendo means to slowly get louder. In this example here at the top, you can see that you start on this pitch C, you climb up to a C, and by the time you return back, you should have grown from pianissimo all the way to fortissimo. So you're getting very quiet all the way to very loud, and you have this many notes to make that change. By the time you get to the middle, you should be halfway through that volume growth. You kind of want to, instead of staying pianissimo until the next to last note, you want to be getting loud from the start, and you will reach your destination by the final note. If we were to flip the direction of this crescendo around and have it go in the other direction, it would go from loud to quiet. And so you can kind of see you start at the tip quietly and you grow to get louder, or you start loud and you shrink to get smaller. That's a crescendo getting louder, and a decrescendo getting smaller. Adds a lot of subtlety to music writing. We also have kind of other common dynamics. These have to do with, instead of growing subtly louder or subtly softer over time, getting suddenly loud or suddenly soft. So words like sforzando and forte piano commonly mean you're playing along and then you're suddenly loud and then you pull back to be suddenly soft again. So it kind of adds an accented moment to the music. And subito piano, on the other hand, means to suddenly get quiet. Now on to our final topic for this unit is timbre, or tone color. Timbre defines the character of a sound. Every instrument has a different sort of tone color. We might use words like smooth, or sharp, or harsh, or gritty, or dark, light, buzzy, mellow, etc. to describe timbre. But again, these are inexact words. These are inexact terms. It's really hard to nail down exactly what you mean because one of these words may mean something different to different people. Most people in the United States pronounce the word timbre. Europeans often pronounce it timbre. But I will know what you mean. It is funny that neither of them reflect the spelling of the word Timbre, but here we are. So, you might be wondering, why do instruments sound different? I mean, it seems so obvious, right? That different things sound differently. It seems obvious to us that different people sound differently. Some people, will say that they're tone deaf, maybe if they're not a great singer or a great instrumentalist, but we can all say that we're, we have great ears if you can tell the difference between your mother's voice and the sound of a freight train. I think Benjamin Zander, the former conductor of the Boston Symphony, used to say. Well, there are three real components that make up the uniqueness of a sound. They are the energy source. So where is the energy coming from? The vibrating element. There's always something that's vibrating. For us, in our voices, the energy source might be our breath. The vibrating elements be our vocal cords. And then we have a resonating chamber, some sort of body or structure that vibrates in sympathy with those vibrating elements and amplifies them and shapes them and colors them somewhat. For us, this would be our chest and nasal cavities, and kind of our nasal passages that change the ways that our voices sound. So these three things come together. Every instrument has these three things. You can break down any instrument, whether it be a brass or a woodwind, or a percussion or a keyboard or a stringed instrument, down to these three basic elements. Even electronic instruments, when we hear them, when they're pumped through some sort of speaker, they have to involve all three of these. Any sound, speech, the sound of the birds flying outside. You might have heard in the distance, as I've been recording this video, there's an ice cream truck driving through my neighborhood. Even the sound of that ice cream truck is made up of these three components. Cool. So here's a list of key terms. I hope that you'll go over these. They'll be especially helpful for the quiz that you'll need to take and for answering your discussion question this week. There's also a list of listening examples. You can click on them here, or there's a larger list on the on D2L that you can go to. I hope that you enjoyed this week's lesson. If you have any questions, please reach out. My email is Kyle, Kyle, .berry, BERRY, @hgtc.edu. All right. Have a great week, and I'll talk to you later.